Morning, folks. A friend of mine came by yesterday and brought me a Vector Research VRX-9000 receiver that's stuck in protection. I'm not sure what's going on with it, but let's crank it up in the dim bulb tester and see what we get. By the way, I received a comment on my channel from a gentleman named Mark Zacharias. I think I've mentioned Mark has a channel on here, has some videos well worth watching. And he admonished me in the nicest, most diplomatic possible way. I should really pop the cover off and give it a quick visual examination before I fire it up. So with that in mind, I've got the cover off and I don't see any components burned or any wires flapping in the breeze. So now we can bring it up on the dim bulb. Mark, thanks a lot. All right, we've got it connected to the dim bulb tester. Let's see what we get. That does not look bad. But looking back at the receiver, our protect light is on. So we're gonna have to take a quick look and see what we think's causing this. All right, so what we want to do is we're going to want to reach down inside with our meter probe and check an emitter resistor on each channel. This way we can see if we've got anything that's pulling or putting out excessive current voltage, and keeping this in protect. So let me get the meter up here where we can both see it. And got to get my probe extender on. Let's see what we get here. Give me a moment, make sure I've got everything in the frame. I got a bad habit of not doing that. Okay. Okay. I think we can both see the meter. And if I go down here to this emitter resistor, I'm only seeing a few millivolts. That doesn't look bad. And if I look here at this one, oh, hang on. Not sure what's going on. There we go, 45 volts. That's why it's in protect. So we may have a shorted output, although we're not pulling excessive current because the dim bulb's not on. This channel looks okay though. So it looks like whatever channel is on the left, and of course we don't know which one that is, translating to the outputs, but we definitely have a problem here. Okay, I'm going to turn it off and we're going to have to take a closer look and see what's going on here. Okay, so I got my probe extenders on and we're going to start taking a look at these transistors. I hope these are okay because these are really funky looking outputs. They call them bat wings. That's probably okay. Yeah. Yeah, I think these outputs are okay. Just out of curiosity, I wonder if there are jumpers we can pull out the back to see where the problem is, although most likely it's in the driver stage and I don't see jumpers on here, so we're probably going to have to pull this out. We're definitely going to have to print out a schematic. Okay, before I pop the schematic up here, I want you to note when I check this transistor, and this is on the affected channel between the base and collector, we get about 0.47, 0.48 volts. That looks okay. But if you notice, we get 0.153, which would not be good for a semiconductor junction, but remember, it's in circuit. And when we check the NPN on the same channel, we get roughly the same thing. Put the red lead on the base, black lead on the collector, we get 0.468. And from the base to emitter, we get 0.162. Now I'm going to pop the schematic up here. We're going to take a look at that, and then we're going to look at where I believe the problem is. So what we checked were our output transistors. You can always identify them because that's where you'll find your very low resistance emitter resistors. These are 0.47 ohm and 5 watt. Those are those big cement blocky looking little guys. And with this off and using the diode test function of our meter, we tested between our base and collector 0.48 volts, which is good. But if you remember, we got like 0.15, 0.16 between the base and emitter. And what that is our base and emitter junction plus the 0.47 plus this 120 ohms that comes back to the base. And that's why we weren't reading the junction as you normally would. They should be more or less the same. We should measure between 0.5, 0.6 between base and emitter and base and collector. But the reason we didn't is the way this transistor's in circuit. I believe what we're going to find is we have a trouble with either our drivers or our pre-drivers or something back this way. But we're going to have to take it a little further apart and take a look. So boy, this thing was fun to take apart. I had a friend named Harry that worked at an automotive shop, and he would work on a car he hadn't worked on before, and he'd have a saying, I have a new least favorite car. I'm kind of feeling that way about this, because in order to get down in here where our problem is, that necessitated pulling this out from beneath the counter module for the tuner display. And boy, was that a bear. But it's the only way to get to anything down in here. So after doing that, I took a schematic that I printed out that we looked at, and I started to write in some of the voltages. Now this schematic thankfully has voltages already, and while I didn't write in everything I got, I was getting, if you recall, about 40 some volts at the base of the output transistors. So I checked these transistors all the way back, diode testing, and they look good. Even tested the front differential pair here, looked good. So then I turned it on and started taking voltage checks from here to here. This is supposed to be 50, it's 46, not too bad. This is supposed to be negative 50.7, it's positive 16.8, that's really not good. This is all supposed to be positive 6, I'm sorry, this is also supposed to be negative 51.3, and it's reading positive 16.2. So this looks like a problem right here. And I'm going to show you what I believe our problem was. If you take a look here, you see we have a 120 ohm resistor with a exclamation point and a triangle. And I believe that's a fusible, and I believe that is our problem. So let's take a look down in there and I'll show you what I've seen. All right, the resistor we're looking at is this guy right down here, and that's R282. So let me put the meter up here and let's see if you can see the meter while I measure this. That looks pretty good. We're in ohms mode. The unit is off, and I'm going to reach down in there. Should be 120 ohms. And yeah, it's over a meg. That resistor is open. That resistor is most likely why we're seeing what we're seeing, because that guy is right here, and it brings the negative 52 volts into the rest of the circuit. So let's get this changed out and see if we have any better luck. Okay, so I've got another 120 ohm resistor soldered in, and I thought, you know what, before I cut the leads off of it, that'll make a really convenient place for us to measure the voltage drop through that resistor and see if there was any reason it blew. If I believe that was a 1/4 watt, so we need to determine if it's pulling more than a 1/4 watt. So I have the meter connected to it, and we're going to turn it on and see what kind of voltage drop we get. Oh, it just came out of protection, and we got about 0.86 volt voltage drop. All right, so let's see how much current that is. Actually, we don't even have to do that. We can take our voltage, 0.86 squared, divided by 120, and that is 0.006 watts. So I don't see any reason why that resistor could have gone open, but they do tend to increase resistance with age. And the more they increase, the warmer they get, and so on and so on. So that was our problem. I did hear it come out of protection. I haven't checked for any offset yet, but let's trim these leads off, take it off the dim bulb, see what we have for offset, and I believe we have a successful repair. One of the problems we have when we're trying to find the component on the other side of the circuit board is judging exactly where it is. And one of the guys on an audio forum I'm a member of suggested this little trick, and it's a great one for certain circuit boards. So we need to find our resistor here. We shine a laser pointer from this side of the board, and that shows our resistor is right there. Let's see here. That should be one end right here, and that should be the other end right there. So I am going to unsolder that. And see if that's the right one. And that's our resistor. So let's take a look at that and see what it looks like with the meter. All right. So, measuring our resistor out of circuit, and it's completely open, just like I suspected. So this is what was causing our problem. Now these are fusible. I'm not sure why this opened up, but we're going to replace it with another fusible because I do believe I have that value. Let's take a look. Okay, so I'm going to fire this up. But by the way, I had to take that support piece out from under the counter module, and I have a piece of cardboard in under here because I didn't want to short anything out underneath it. So that's a good thing to do. Meantime, we're going to fire this thing up and see if we have any offset. I've taken it off the dim bulb, and there's our 2 meters. Top is left channel, bottom's right. If we have offset, there's no adjustment. We'll have to change out the differential or long tail pair in the front end of this thing. Okay, we got it turned on. It's out of protection. Offset is not bad at all. Not bad at all. We're down in the 1 to 2 millivolt range. We're down in the microvolts on the right channel. So, next thing we're going to do is put some YouTube safe music on, check this thing out. Alright, so let's see what we can get this thing to do. Came out of protection.
I know you told your friend you're not okay, and tell me what's wrong and why you never said you felt that way. Guess you're trying to stay strong and fake a smile until I look away. But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away, as you fade away.
Alright, sounds pretty good. So the only problem we had was this resistor right here. And our voltage checks are what pointed us to it. Now I tried testing the transistors, they all tested good because they were good. It was only after turning it on and being able to check the voltages, because everything was bad in here. And it was bad because we had no negative voltage here. Remember, when these output stages are working properly, everything is balanced through here. You can see this says positive 1.1 volts here, and this is going to say negative 1.1 volts here. And when we drop across these junctions, our net output here should be 0 volts DC. So if we have 1.1, drop 0.6, we have 0.5, 0.6 here, drop 0.6 across this junction, because remember, a forward bias transistor junction will drop about 0.6 volts. This is negative 0.6, it's a PNP transistor. The net result here should be 0 volts. Everything should be balanced. We have a positive rail here of 52 volts, a negative rail here of 52. That's the way this all has to work. And our voltage checks pointed out that we had a problem here, and we traced it right to this resistor. Replacing that restored normal operation. So that's where we're going to leave this one off. I'm going to reassemble it off camera so you don't have to listen to me curse. Anyhow, I hope you enjoyed this video, and I hope you learned something. And I did. I have a new least favorite receiver. Thanks for that one, Harry. And as always, I like giving back to the community that's given me so much. Thanks a lot, everyone.